welcome to the session. Thanks for coming. Thanks for coming back after lunch. Try not to fall asleep. Don't do the food coma thing. This is Frank. Frank's going to talk to you about building proper connection to cloud services. At the end, we're going to give away a prize. One of these. So take it away, Frank.
You should not show that on front, because otherwise the people will leave here.
I'm watching it.
Somewhere else. Come in. There's a lot of space in the front row. We are not in a church here. You can sit in the front row. My name is Frank. I'm from Germany, so pardon about my English. I finished my class with a second worst rating, and I always practice. My story is I'm one of the founders of Net@Work, a company in Germany. You can have the PowerPoints afterwards. They're already in the session builder, I think. I have uploaded the PDF, so you can make photos or pictures if you want. There are no videos, nothing like that. I have more slides than I can show you or can tell you. It depends on the questions you're asking. So if there are any questions, raise your hand, simply ask of that. I have a bunch of sessions. Let's see how far we go today. Before I start the technical stuff, who of you is a networking guy configuring firewalls and SNMP, Nagios, CheckMK, things like that? Who's a networking guy? Who is alive? No hand. Who is not a networking guy? Okay. Anyway, so I try to lower down the networking technology and rise more the Teams technology. Think about trucks. Think about you have a production plant and you're delivering goods to your customers. And you are the gatekeeper sitting at the gate and counting trucks and measuring the weight of the trucks. That's what networking guys are doing today. They use SNMP, Simple Network Management Protocol, to read the number of packets receiving and sending through the firewall and the size of the packets. And they make big bandwidth diagrams over days, hours, weeks, and so on. The question is, does this help for your cloud connection? What does it tell you about the packets you want to deliver to your customer if the packet leaves your network? Or if your gate is empty and say, oh, I don't have a problem, I have no congestion, everything is working fine, but you are not aware that 10 miles away a junction is congested or there's a traffic jam somewhere. So we have to think about how can we measure cloud performance in the future. So we have to change our monitoring. And then think the other story, the last 3 years. 2 years ago, 3 years ago, I were asked all the time, Frank, we want to go to the Office 365 world, how many bandwidth do we need? Is our 100 megabit connection fine? Is it sufficient for our cloud? What can you do? Can you do some kind of assessment to tell us what we need? We know that's very difficult. You can ask your local Exchange server, what else, and you have to make assumptions, but that was the past. And then COVID arrives. 90% of all my customers were working the home office. And they were using Skype for Business on-premise, or they tried to use it, and we all know that will not work. So they were adopting Teams very quickly. So about 50% of them used Teams within the first 4 weeks after going to the home office. Nobody cares about licenses, and nobody cares about security, even in Germany. And then, 1 year later, back to work was the new wording. All have to go back. The only problem is the people did not change their way how they work. They still use Teams, they still use OneNote and OneDrive and all that stuff, all the new fancy cloud stuff. And now we have the reverse direction, that people are sitting in the office building and try to connect to the cloud, and now we have a big bandwidth issue. And with that in mind, I think I have 3 slides from Microsoft, and I will only show one of you for that. I think you know these pictures somewhere. Have you seen them? Hopefully, because they are from the official Microsofts. They are on Microsoft YouTube, they are on Microsoft Tech, what else? You can see them everywhere. But Microsoft don't tell you what they mean about that and how you can check if what they tell you is correct. Or if you have the correct implementation. And I want to show you what happens if you do something wrong. Simply some samples. And you also know the Exchange endpoints. I skipped that. You can have that for a reference later. Let's talk about the global Microsoft network. The Microsoft is offering a global network. They tell me it's the second largest network in the world. I assume that the Google network is a little bit bigger because YouTube and other stuff, but I don't know. And if you look around, that's a massive amount of numbers. 44 million IPv4 addresses, public addresses owned by Microsoft. And a lot of more IPv6 addresses. You can use these URLs to get the current numbers. The numbers are really growing again. But now let's go back, downsize to our own network. Think about your own network. You have your headquarter, you have a remote location somewhere, you have someone in the home office. Of course, your headquarter has an internet connection using an ISP, Internet Service Provider. And Microsoft is on top. The Microsoft Global Network is, for example, connecting to one of the data centers in EMEA. UK has their own data centers, but we're in Europe, and so it's EMEA. The first thing you can check is, what is your company doing? Is it using this connection, or is it using that connection? Is there a direct connection from Microsoft to your ISP? Has anyone checked that before? Why? Who has checked it? One I have seen, one guy saying yes, two. What are doing the others? Have you ever tried that? I'm sitting in a small company called Parabon, and we had our local city carrier, which has upstream to the next energy carrier, and then it's going to the D6. That was 2 years ago. Today, we have a direct connection, and that's what Microsoft is doing. Microsoft tries to connect mostly directly to your ISP. But that's only one location. The global network is worldwide spanned, and Microsoft promises it's QoS managed, it has low jitter, it has no packet loss. Come on, no packet loss. That's a challenge. And we have to know that our home office is using another ISP. And even my remote location is using another ISP. And that makes the thing more complex. If you are sitting in your home office, which way is your system going? Is it using this one? Is it using this one? Is it maybe using this one? Let's find out what your system is doing. Microsoft tells you, we use a hot potato principle. If you send a packet, for example, to Amazon, your ISP will check the destination IP and say, oh, that's not in my network, go out of my network. Where's the next exit point? The other company should take care of that packet. Microsoft has the reverse direction. They tell me, we want to have a large path in the Microsoft network. So the optimum situation is, your company has a breakout and that's 2 or 3 hops, and then you're in the Microsoft network. So that is not really internet, that's your ISP. The only thing why this is not so fair is your internal network, your remote location uses your own network. And that's the third story. The best idea is every PC should leave your location as soon as possible to the internet. But Microsoft is going the reverse direction to your ISV to have the direct connection here. Sample from the practice, I have a customer in Hamburg with a location in Dubai. The latency from Dubai to Hamburg is 10 milliseconds slower than from Dubai over the internet to the mailbox in Amsterdam. The networking guys got crazy because hey, we have a great network. Yeah, but Microsoft has a better one. So why don't use the Microsoft network? And to get the peerings, you know about the Microsoft peering policy. You can check it here, public stuff. If you want to have a peering with Microsoft, it's not for home office users, and not even for small companies. It's for service providers. If you want to get more of these, who is aware of peeringdb.com? Peeringdb.com, never heard? Let's see if the internet is working here. Peeringdb.com is a database, and you can see who is the sponsor of that. So you can trust that these numbers are fine, and if you go to Microsoft, which is a BGP network 75, yeah, and you see all the peerings Microsoft has to public peering points and even to private peering points. Simply have a look where you are. You can also check the speed they use, and you can also check for common internet exchange points. And if you do that, for example, you go to D6, for example, that's in Germany one. Where is it? Frankfurt, let's take Hamburg, that's fine too. And let's sort it by the speed. And you can see which is connected to that. And you see Microsoft is not in the top 10 list because they don't want your traffic to travel through these exchange points. They go to the carrier directly. So Microsoft definitely knows which source IP address is calling the service in the cloud, and they see the amount of volume and the latency, and can say, hey, this provider needs a better connection to us because they have customers from us who pay for Office 365. So let's play for that. And now let's look, what with the DNS stuff? What do you think? That's a normal setup, I assume. Correct me if I'm wrong. You have a client asking your domain controller about the DNS. Your domain controller might ask the firewall or might ask the DNS provider of your ISP, and this is asking Microsoft. So Microsoft can see an incoming query for office365.com from this ISP and returns the best entry point for this ISP. What happens if you're in your remote location? Is that the real setup in your situation? Your PC asks the domain controller in the remote location. If that domain controller does not know the address, he forwards the DNS query to the central location. In about 50% of my customers, that was the reality before I asked them what's going on. And the question is, what will happen if that's going wrong? So let's simply use a ZMD shell and simply start that query, and you see I'm here and I get that's the best entry point for staying here. Now think about I'm working for a Japanese company and my headquarters sits somewhere in Tokyo, and I'm asking a DNS server in Tokyo, and Tokyo is asking the DNS server over there, and Microsoft is sending an answer. There's a DNS server around in Asia Pacific, and you got that as an answer. Anybody aware what MDW is? Very easy. It's a IATA code of the airport. That's Chicago Midway. So I'm sitting here in London. My DNS setup is scrambled. I'm asking the wrong DNS server, and to get the answer, connect to the Exchange server in Chicago. Should we do a connection for that? No problem. We can simply do that. I will simply do a connection to the Exchange server here in London, for example. I use the FAF icon. You need the Outlook icon on top of the address bar, and we get a 7,000 byte image back. Not a big deal. And now I measure the time. How long does that take? You can see 90, 80 milliseconds, 70 milliseconds, something around that. That's what it takes from here to connect to Exchange entry point by Microsoft in London Heathrow. And the next thing is, I connect to this other server for the MDW, for example, MDW, sorry, and you can see it. Oh, it was about 400 milliseconds, because that's true. I'm connecting to the United States and back to me. So a simple DNS misconfiguration will bring you into problems. Question. Who is using another DNS server like Google? 1, 3, 4. Do you imagine what's going wrong? Let's try it here. I will simply do a DNS query against Google. I'm not sure where the Google servers are in London. Maybe they are nearby and we get the same answer. Yeah, we get the same answer. Let's try one of these Switzerland servers. No, everything is London Heathrow. Okay, they have a proper setup. But most of the time you can see the not optimal server, because the Google servers may be located at another carrier, like I show you here. So if your DNS server is asking this one, and this server is asking Microsoft, Microsoft will return this entry point, and not this one. So use the right DNS setup, that's essential. Now let's talk about the home office users. Who is using a VPN tunnel? Still 1, 2, okay. I've put all files. So think about we have a home office with a tunnel. What happens then? My PC does a DNS resolution using the company's DNS server, getting this entry point. If you have a tunnel, your packet travels this way, the peering from ISP, from your home ISP to the company ISP, to your VPN server, back to this. Not optimal. If you, hey, I have a split DNS, I have a split tunnel, great. You are leaving that here, and you're traveling this way. So split tunnel is not sufficient. You have to use split tunnel and split DNS. So tell your Windows client to resolve your internal names using the internal DNS server and everything else using your local DNS server from your router, from your Fritzbox or whatever your DSL provider is. Anyone heard about NRPT? Name Resolution Proxy Table? It's a group policy you can use to tell Windows which DNS server should I use for what domain. So use that and say Active Directory.internal, use this private IP address, everything else use the assigned IP address from your DHCP server. The other slides are simply here for reference to see how it works if you go wrong and if I don't have an internet connection. So keep in mind, watch your DNS servers, use the right DNS servers, the right ordering, the right direction, and verify that. Simply do an NS lookup for OutlookOffice365.com, check the airport code, is it nearby or is it somewhere else? But Microsoft helps you. There's something called Anycast IP. I think you know this IP address 8888. And we all know the internet has redundant paths from your client to the server. If something is broken, it still works. And we also know as a company I can have 2 ISPs with a provider independent subnet and to publish both routes. So if that ISP is broken, I'm still reachable. And the trick is now, I cut that in between. So I put one server in the US with the IP address, another server in Europe with the IP address. And the first answer is, come on, Frank. IP addresses are unique in the internet. You cannot have 2 servers with the same IP address. Not really, you can have. You simply have to make sure that all servers are answering the same query with the same question with the same answer. If that's given, it's possible. And that's what Microsoft is doing for some services. So this fixes some wrong DNS configurations. And I will show that with a sample on Teams, for example. If I do an lookup for teams.microsoft.com, you get an IP address. Simply have a look at this. And now I'm asking the server in China. Takes a little bit longer for the answer, but the IP address is the same. So all Teams servers in the internet have the same IP address as entry point. Teams will then do a redirect or what else, fancy thing or what else. But because Microsoft is doing that, they help you, or they help themselves to fix invalid DNS configurations on the client side. But Outlook is still using GeoDNS. So I have a list of that, which service is using what. So Exchange Online is here using if you use that, you get geographical entry points. If you use SharePoint, for example, then you have the same IP address per tenant. Teams is using that. Another thing is the Teams audio stuff. What happens if you start in Teams a meeting? Your Teams client connects to a given IP address, but it's not an IP address, it's the name. And the name is something strange. It's worldinz.teams.microsoft.com. Crazy. Anyway, and you see, I get the feedback from West Europe. I do this again. North Europe. West Europe. West Europe. Sometimes North Europe. Okay. So I'm switching between. You can do that 1,000 times, and sometimes you will get France Central, North Europe, UK East, UK South, what else? And if I do the same query again, my lovely server in China, that's something like Google China, and then you get an answer from Japan West. If you want to play with that, the Germans have a famous web page for that. It's German, like Surf Without Filters, and they list DNS servers in the world you can ask for free. So if you want to get an answer, how does a server in South America resolve a certain name to what IP address? Simply take one of these and answer that. But it does not. It helps with Microsoft Anycast that you no longer have to care about that. Okay, that's DNS stuff. I try to stay in the time. Let's do some TCP details. Think about the following. I have one PC, I have one server. PC on the left, server on the right. Unlimited CPU, unlimited disk, unlimited network. Everything is unlimited. The only limitation is 20 milliseconds in between. What's the maximum bandwidth I can use for FTP for a transfer? I heard at the beginning there's no network, guys, so I will not stress this a lot. So let's start easy. Think about TCP version 0.1. I send a packet with 1,514 bytes to the remote site. I get the acknowledgement back. I send the next packet. If TCP would work like that, then the maximum speed is 75 kilobyte. That's not true, because TCP/IP uses a window size. So the sending machine sends a bunch of packets, like you order on Amazon 20 packets, and the delivery hero will fill up your entry, and then you say one signature, everything arrived. But the question is, the sender and the recipient have to negotiate what's the maximum packet size. And the question is, what do we expect? Kilobytes, megabytes? Because the 20 milliseconds are still there. If I can send a megabyte and get acknowledged every 20 milliseconds, then I'm limited to 50 megabytes per second. And the thing is, it depends. A web server normally uses smaller window sizes. A firewall in between with deep inspection, what do you think what a firewall thinks if I say, hey, I want to send you some bytes, can I have a gigabyte buffer? Yeah, of course. And then I start sending packets, packet 1, packet 2, packing 10,000. And the firewall says, packet 1, packet 2, packet 10,000. There's something missing. I have to delay that packets and wait for the remaining packets, and I have to reserve the buffer for that. So it's a risk for an attacker. And the thing is, if you look around, if you do Exchange Web Services, the window size I have seen is 1 megabyte. OneDrive uploads, SharePoint downloads, different sizes. And now think about your own network. You have Outlook in your network, you have Exchange in your network. Latency is 1 millisecond. We are in the gigabyte level. It doesn't matter. But think about 20 milliseconds. If you have 20 milliseconds in between, and you use EWS to import and export files with a migration tool, 50 megabytes per second, in the optimal way. Did we have 20 milliseconds? Remember my invoke web request for the icon? 80 milliseconds. Now let's see what happens if we have 100. So the throughput is going down immediately if the latency rises. And that's the reason why I tell you latency is much more important than bandwidth. And that's only if everything is working fine. What starts with packet loss? For example, if you have 0.1% packet loss about here, then your throughput will go from 31 to 8 maybe, 30%. If you have 1 packet lost every 1,000 packets. Because what happens, I send packets, one gets lost, and the receiver says, stop, please, I need that packet, everything else has to wait to get it. So packet loss is the next key you have to check. Who is counting packet loss on the internet currently? No. why are you not using the FUF icon test every second to grab these funny icon to see if it's lost? The solution for that is Microsoft starts using multiple connections, because everything I told you is on a per connection base. So that's the reason why Outlook uses one connection for new mails, for sending mails, for offline address book, and all of that stuff. Teams is the same. One session for signaling, one for status, one for updates, one for channels, one for chats. Connections. And that brings us to the next problem. I will skip some slides due to the time. That's the stuff with the ports. You have a client, connects to your router or your proxy, doesn't matter, goes to server. The next client uses another port, the next client uses another port. This will not happen. The port is not reused because it's associated to a connection. And the question is now, how many connections can you have on a single outgoing IP address? What do you think? Unlimited? Million? 60,000? 1,000?
It's 65,000.
Yes, 16-bit. So you have 65,535. You have to get rid of the lower ones because they are reserved. The upper ones are reserved for the host itself to connect outgoing. So think about 50,000 connections. Okay, question, how many connections is your client using as a normal Office 365 client? What do you think? 10, 20, 100? It's very easy. You can measure that. It's a simple PowerShell command. My current PC, if it returns, has currently 25 established connections and some are on timeout. So 30, 40, safeguard, maybe 50. So what happens who has more than 1,000 users on one site? How many public IP addresses do you use?
Customer bingo had one, and they ran into a few.
The issue is sometimes it works, sometimes it does not. Sometimes you download a SharePoint site and the image is missing. Sometimes the style sheet is missing because the firewall is running out of TCP connections. So the thing is, simply measure it. Ask your firewall. That's a live graphic from my home network in the company. That's our baseline, and you can see Monday, Tuesday, Wednesday, Thursday. We run from 3,700 to about 6,000, about 3,000 connections, and we have about 80 people in that location, 50 per user. So calculate the 50 connections per active user. Maybe you have to add some numbers for IoT devices and what else you have in the near future. But that can kill your story. And even your firewall has to clean up the connections. For example, your user is leaving the office. Does he really shut down the PC? No. Close the lid, leave the office, go out of the wireless range, and the firewall says, oops, there's still a connection. How long does it take for your firewall to clean up that connection? 2 hours? 10 hours? 5 minutes? If it's too long, you consume too much resources, and the RFC tells me a normal TCP stack can keep a connection idle for about 2 hours. No one is doing that. Just kidding. But if you do it too short, you will have another problem. Your Outlook is asking, hey, Exchange Server Online, do I have a new mail? And Exchange Online does nothing. Nobody tells me I have to answer immediately. I simply delay that answer. And maybe 10 minutes later, oh, here's the answer for your questions 10 minutes ago. And the firewall says, sorry, I don't know where I have to deliver that packet because that session was idle too long. And the story is here, you have to make sure that your timeout for sessions is arising from the internet to the client. Otherwise, you will go into trouble. And now let's talk about Teams. Sorry, if I'm too fast for you, ask. Raise your hand, otherwise I continue. Now we're here because Teams is the story of. I always tell you, Teams is a canary in your coal mine. Or I am from Palatina, it's a canary in my winery. It's both the same. If the canary is not singing anymore, you have to leave the mine or the winery, because carbon dioxide may kill you. But that's what we are talking about. All I told you in the past was about TCP, HTTP. Teams is using that for apps, files, channels, all of that stuff. And now let's talk about audio and video. Oh, the headline is lost here. There's a big difference between TCP and UDP. TCP means connection-oriented, no loss, reliable. The endpoints make sure that packets are arriving in order without any loss. Everything is fine, but there's one big problem. If there's a packet loss, the receiver will not continue playing the data until the missing packet has arrived. What does that mean for audio? I'm talking to you. If I would do that with Teams, my PC is capturing my audio in 20 milliseconds intervals, use an analog to digital converter and send packets. Every PC using audio is sending 50 packets per second continuously, small packets. That's audio. And if a packet is lost, who cares? Requesting it and resending it takes longer. We cannot stop the time. We don't have a time machine. Simply ignore it. If a packet is lost, it's lost. Who cares? The benefit is if the receiving side detects this packet loss, the receiver can tell the sender, please adjust your output, reduce the resolution of the video, go down from wideband to narrowband, don't use stereo, use mono, things like that. Change your codec. If you use TCP because UDP is not allowed, the receiver cannot detect packet loss. He simply detects, oh, there was a gap. Oh, but everything is there. It arrives a little bit late, but who cares? Oh, it's too late, just drop it. Why should I resend something if I drop it? That's the reason why we use UDP. And Microsoft has a clear statement, and that's an important statement I always use. If the firewall security guys tells me we can't use UDP, UDP is unsecure. We have to use TCP because we have stateful inspection with TCP. And we can use deep inspection with SSL offloading, all that stuff. And UDP is devil's stuff. No. The clear statement is, blocking these ports is unsupported and will have an effect on media quality. That's my question then, do you want to be supported or unsupported? That's a big decision. But the technical guy is more important to tell the people what they are doing. UDP is a must for Teams. I will show you later how you can check if UDP is used. And now let's have a look inside the normal Teams communication channel. A normal picture, I have a company with two sites. I have a VPN to a home office. I have internet with some ISPs, and I have the Microsoft Global Network backend with everything. What happens if user 1 and user 2 is doing a voice call? The audio video stream is using the direct connection from the private IP to the private IP. As long as it's in routed subnets, the audio will be internally. It's totally up to you to manage your network, your latency, your bandwidth, all you want to have. If I'm using a VPN connection with it, even if it's tunnel or not, this PC has a private connection, private IP, and this has a private IP from your network. And tunnel or not, doesn't matter. And the connection is going that. Do you really want to have this audio video stream traveling through the VPN tunnel? Who is using IP HTTP VPN tunnel? Because that means Teams is sending UDP and the VPN server is encapsulating them in TCP. And even worse, in HTTP over TCP or in UDP. Nothing in what you really want. You can block that. For example, you know these are the source and destination ports for audio, video, and screen sharing. Simply block them. And if you block them, this will happen. The home office user, split VPN of course, will send the packets to the media relay nearest to the home office user, and the company user will send his own media data to the media relay nearest to this ISP. And Microsoft is doing the backbone for that. You are already paying for that. Simply do it. The same is in your company. You can block UDP on your internal network. Simply configure static ports for source and destination, block it, and then both will use a Microsoft backend. Simple stuff to optimize that. One more is audio-video conferencing. That's another story. There's no direct connection. The first user who starts the conference is responsible for the location of the conference. So if you're sitting in Europe and you have a conference with 10 European guys and 1 Japanese guy, make sure that one of the European guys is the first in the conference. Otherwise, the conference will be hosted in Japan. And then everyone will connect to this media, to the MCU of the first user. Small trick. If you are the organizer, join early. So the conference MCU is nearby your location and not from the other one. These are the Microsoft statements. I think you all know that. The only thing is, how do you measure that? Anyone aware of the Microsoft Teams network assessment tool? Hey, yeah, I got some feedback here. So I do not have to show it. It's a nice tool which definitely tests some endpoints. You see the ports? Everything should be green or not red. That's great. If you started with quality check parameter, it does also 32 voice calls and generate a CSV file with all the data in there. Pretty nice. But it's not only Teams. Are you sure that your users are not also using Zoom or Google Meet because they are invited to other companies? They use the same stuff. That's a sample from Google, for example. If you want to check the latency to Google, ping lens.google.com, and then the most important session, if your latency is not 100 milliseconds, 100, the magic 100 again, or use the trace route to find the path and find out why it's not that good. And one more sentence, don't average. Average does not help. It's like the pizza stuff, I will tell you as the next one. So I have to check, that's the past. I was monitoring my firewall, my servers, my clients, everything was fine. It does not work for the internet because Microsoft is doing monitoring, but they don't show us any counters. In my local area network or in my wide area network, I don't see any Office 365 packets if my setup is correct. So no way to do that. My ISV will definitely not show me any internals. I can see more traffic on the firewall, but the best thing is I have to adjust my monitoring to get more data from my system. Everything we are doing in the past is not working. And now the question, how do we monitoring that stuff? And ping was one sample. I showed you the invoke web request to do that. And I have some tools about that. I call them end-to-end monitoring. They are free. They're simple PowerShell scripts. And that, for example, I think that's a ping test. Yeah, that's a ping test. I'm doing a continuous ping from this PC to a given endpoint. I think it's Microsoft Internet Beacon test, I'm not sure. So I have no access to any routers here, to any wireless infrastructure, what else, but I still have information about the network quality. Because if I'm not traveling to Heathrow on the motorway because it's congested, I can see that. I don't have to be the British Transport Organization to read all the data from the bridges or what else. So I can see it was pretty nice between 1 p.m. and now. I think that's German time, sorry. And currently there are some timeouts here. Pretty easy. You can just do the same with UDP, because UDP, that's what it looks like here. That's a dangerous tool. It sends 50 packets per second to Microsoft to say, hey Microsoft, I want a turn candidate from you. And Microsoft tells me 401, access denied, please send your credentials. And I simply say, I don't have to answer that. I don't have credentials. Why should I use credentials? I send a packet, I get an answer, so I know the port is open, it's reachable, and I have a latency. That's all. I do that for more than 2 years now. No denial of service protection or whatever, because every of your Teams clients is doing that. And every time you start a voice call, you do the same. And during a voice call, you do that 50 times per second. And if you add video, you do it even 200 times more. So if you have 1,000 people, 20% are in a voice call, so you have 200 people in audio, you have 200 times 50 packets. Means 10,000 packets per second, continuous data stream to Microsoft with answers. So my 50 per seconds are low under the radar. Nobody really knows that. So that's a thing what you have to do. So think about latency is more important than bandwidth. Don't measure every minute. That's not sufficient enough. You have to do it more granular. Every second, every tenth of a second. It depends what your requirements are. But it's a cloud. And don't do any averages. Do percentile. Somebody here who knows what a percentile is? Come on, who studied math? Okay, let's do this a simple sample to stay in the time. Think about your Italian pizza bakery. And you bake pizza and you use a driver to deliver it to your customer. And the driver tells you, by the way, it takes me 10 minutes to deliver the pizza to your customer. What's your answer? Sorry, that information is useless. The meaning can be 50% have the pizza within 5 minutes and the other 50% have it within 15 minutes. So 50% not happy customers. The real answer for me is more, it would be great to say 95% of my customers have a hot pizza. And that's something you have to define. What is your goal? What's the watermark you have to reach, the level? And if you say, we want to have 99% of packets to Teams arriving within 100 milliseconds, then you are great. And then you have to find out, how can we do that measurement? And that's what I have shown you. These samples, I switch about that because I have to show that in live. That's only my backup if the internet is not working. Some comparisons, yeah, that's German Bundesbahn. Austrian Bundesbahn is the same. I have not tried it in the UK with the buses, but I assume it's the same. Latency is horrible here. If you want to do your own tests, these are interesting endpoints. You can simply query them. They will always answer without any authentication. So you do not have to supply any OAuth tokens or username password. Simply ask them what you have to do. And sometimes you will get, hurry up.
3 minutes.
Sometimes you get some interesting facts like that's a download of a 700K file, which sometimes takes 100 milliseconds. Great means 66 megabit. And some seconds earlier, it was 5 seconds. So this line of this customer was flippy all the time, within seconds. The normal networking guys say, I have 20% utilization, everything is fine. Does not help. By the way, if you do that, if you do an invoke web request against the FAF icons, you will get information like this here. And that's funny. I did that in December 2019. I have seen new data center from Microsoft, Frankfurt and Berlin, arriving in my responses. So I did a FAF icon query every second and wrote down which server answered me. And if you do that often enough, you can find out where are the servers, what is the distribution, and even I can find out if Microsoft has an outage somewhere. The users will not detect that because DNS from Microsoft will switch that within 5 seconds. But I can see that there's no answer anymore from Frankfurt. The same is for SharePoint. If you want to measure SharePoint, these two headers are always in every SharePoint response. I can simply grab that. I can write pictures. I think I gave you an idea, and what you should do in your network, make sure that your configuration is fine. That's something you can check and test. Make sure that your clients can use the right connection, for example, UDP for Teams. And if you want to make it perfect, find something who measures what you promise. And don't trust any call records from Teams afterwards, because they only show you when the call is finished. It's not a continuous monitoring for that. I think that's nearly everything. Checklist is for you.
Questions or answers? You got 30 seconds. Questions?
Otherwise, I will stay outside.
Where can we find those scripts?
The videos will be posted at some point in the future.
Yeah, they are all public. Simply search for end-to-end, and yeah, it's unfortunately it's everything German, but PowerShell is language independent. Oh, by the way, it's English. And Google Translation is doing a lot of stuff. So here you can find the end-to-end. Where is it? I'm on. The HTTP stuff, the ping stuff, here the UDP test. Otherwise, send me email, frankcarriers@network.de. Simply